So here's the deal. Over the next few days, this is what we have coming up. We got school Monday. There is no school Tuesday. It's Veterans Day. We have school Wednesday. We have school Thursday. We also have school Friday. However, I have another day of pre-surgical doctor appointment things. It will be my last day of pre-surgical doctor appointment things. So I won't be in on Friday. We'll probably tell you don't do your work, don't do your homework Thursday night, and then you can do your homework in class on Friday. Okay? I'm going to try to get Jimmy to sub for me again. I don't know if they can do that, but I got to talk to him, see if he's free. If he's free, then we'll get the whole thing done. I believe it's going to be possible. Then when we get back, the week after that, I will be in every day that week. And then the week after that is the week of Thanksgiving, and that's the week I go out to get my knees done. So what we're going to do is teach like crazy, with the exception of that Friday, all the way up until the week of Thanksgiving. The week of Thanksgiving, we are going to do a pre-test Monday, a pre-test Tuesday, and a test the day before Thanksgiving on that Wednesday. Then you're going to go home early on the Wednesday before Thanksgiving, but it doesn't affect me because I don't have eighth period classes. Then when you come back, we're going to work a combination of days where I teach via a video. I will record a video. Jimmy will present the video. It'll be like when you do the relearn packets and you watch a video that's from the relearn packet. It'll be just like that in class. So we'll probably do 3 or 4 days of that stuff the first week, and then have an assignment where you all work together on Friday to make sure you understand the work from the week. And then the week after that, the same exact thing. I will definitely be out at least 2 weeks. There is no way on the face of the earth I'll be back within 2 weeks. Possibly that Friday. I am doing everything in my power to be back in on that Friday. But realistically, the following week at some point, I will be back in. So we'll see how it all shakes out. Now, I was a little bit disappointed with your quizzes, and I think that the reason I think will become pretty apparent. It's really important. Alan, you with me here, bud? All right, yeah, I know you're here, but listening and hearing are two different things. It's really important that you go into something with the right mindset, that you have a strategy for approaching these problems. And one of the things that I told you when it comes to word problems, the hardest thing about word problems is kids don't know where to start. That's one of the things we talked about, and we talked about the need to set up tables or to draw pictures and how important that is. Yet, take a quick look at your quiz I returned to you just a couple of minutes ago, because we're going to go over that. Okay? If you take a quick look at that quiz, I think many of you will see that you didn't even put a table on it. And that's a huge mistake if you did not put a table. I want to see a table. The table will guide you through the work that you have to do. In the next class, kids did do a table, and their grades were significantly higher than your grades. The second thing I want to mention is that the difference between arithmetic and algebra. Now, this course is a pre-algebra course. You're supposed to be learning how to use algebra. And more kids used algebra on yesterday's quiz, but not all of you. Some of you still tried to use arithmetic. If you take a quick look at your paper, if you don't see a variable on your paper, if you don't see an X somewhere, or an N or something like that, then there's no way that you used algebra. So what we're going to do now is, whatchamacallit? Somebody get that, please? I hate that it's there. I am going to show you the paper that a student did for his quiz. What's that?
The lady wanted to know if something on the red was.
Okay, and you told her yes or no or whatever? All right, I apologize. I actually scanned this with the wrong side up, so I have to scan it again. This is going to take just a moment. But I want to show you the work that someone did on their. This is the work of one of the students, one of your peers. So it's nothing that I made up, and for the most part, he did a great job. So let's get this going here. It'll take just a moment to scan in. I did scan. I scanned the wrong side. I scanned the back of it. Stupid me. Okay. So next week we'll have 3 quizzes again. The week after that, oh come on already. The week after that we will have all lessons and then test the week after that. Right. Like I got nothing better to do than sit here and answer a phone. It's actually a fairly convenient time. All right. Yes. Hello. Yes. Yes. Okay, can I just ask him real quick? Franklin, you didn't sign in today. What's the deal?
Came late.
Yes, we know that. Why didn't you go to attendance and sign in late?
Oh, please.
You had a brain cramp. So I'll send it down at the end of the period, okay? That happens again, public execution. Got it, buddy? All right, we're good. You gotta sign in when you come into school late. Okay, now, let's take a look at the work that this young man did. He's been working real hard in class, and God bless. He did a very, very, very nice job.
I'm in this class right now.
No, he's in the next period class. I'm going to show his thing. Why, oh, why, oh, why? This is scan not up. Looking for scan 8, I believe. There's scan 8 listed up here. Why? You know what? You would think 1010. Why is this happening? I just scanned this. This is his work. And this is what pops up. This is like ridiculous. All right, let's try this again. Let's see how this works. It's got to be on here somewhere. Today. No. All right. What is going on that this is not appearing? This is to show you how a trained professional handles an emergency situation. All right, so this should be scanning. File. What an absolute pain in the butt this is. System preferences. Print and fax. This. Scan. Open scanner. And scan. All right. Now we are scanning. Okay, it is appearing. Okay, it seems to be done. All right, so let's see here. All right, so here is it in preview. So it's definitely on there. All right, so let's get rid of that. Let's get rid of that. Let's get rid of that. And let's look for scan 8. There we go. Dun, 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 dun. Okay, so this is Michael Lacero's paper. He got an 80 because he actually messed it up a little bit after doing some beautiful work. So let's go through what he has here. First off, what do you think this means on the side here? Right, Monday, Tuesday, Wednesday, Thursday, Friday. Look at your paper for a second. Doesn't it say on there that on Monday this, on Tuesday that, on Wednesday this, on Thursday that, on Friday that? Don't you read that all on there? So that's what Michael does. So he writes down that on Monday there are 40 tickets sold. And then it says here, if we take a look, on Tuesday a certain number of tickets are sold. So he calls that number N. Makes sense, right? Now, this is algebra. The minute he starts using algebra, if he gets his table set up properly, he's automatically got half credit. Automatically half credit if he can get that much done. Now, Wednesday, it says he sold 10 more tickets than Tuesday. Now, what operation is more than? Addition. So look, 10 more than Tuesday. So here's Tuesday, which is n. So Wednesday is 10 more than that, so it's n plus 10. Then Thursday, it says, sold the same number of tickets as Wednesday. So he looked at Wednesday and he put the same thing for Thursday. It says it's the same amount. Then it says Friday, he sold 5 less tickets than Tuesday. So let's go back to Tuesday. What was Tuesday again? N. How do you say 5 less than n? N minus 5. And then he comes off over here and he writes the equation. 40 plus n, there's 40 plus n plus 10, that's Wednesday, plus another n plus 10, that's Thursday, plus an n minus 5, that's Friday. So all he did was take each of the days, add them up, and say, hey, that's got to be the total, which is 250. Now he's working on getting like a 65. Then he goes out and he solves the whole thing. Actually, he's more like working on a 75. Then he goes out and he solves the whole thing. You can see down here, he adds up the n's. Same side, same operation. 1n, 2n, 3n, 4n's. So here's just 4n's. Then he has 40, 50 for this 10, 60 for this 10. Then it says minus 5. So it goes down to 55. So 4n plus 55 is 250. He minuses 55 from both sides. And here's where I made a problem that didn't work out perfectly. I apologize. It's 195 over 4. So he is perfect so far. The only problem is it wanted to know the number of tickets sold on Wednesday. On Wednesday, you got to add 10. Okay? So he should have added 10 to his answer here. Now, because he didn't add 10, he lost 10 points. And then over here, look what he does. He changes things a little. So I took off another 10 points for why he changed things. I don't understand why he changed things, but he did. So he lost 10 points for that. Okay? What's the first thing you do every time you set up one of these problems? Table or picture. If it was about a rectangle or something like that, you do a picture. This one is not about that, so you go with a table. Monday, Tuesday, Wednesday, Thursday, Friday. Expressions for each. Add up. Solve the equation. Okay, so I will shrink that down, and here's your quiz. I probably won't get your quiz graded until later today. In fact, I'm sure I won't. If you want to, sure. Remember, no arithmetic, algebra. What does algebra mean it has to have in it? Variables, n's, x's, things like that. I'm going to give you about 4 minutes to get this done. And then I'm collecting them, and then I will grade them later. Yes? Got an extra? Done already? Oh, it's an extra? Okay. I was going to say, man, you're fast. Thank you. Thank you. We have about another minute, guys. Shh. Alan, no noise. Nice setup, Kevin. Good job. Now we just have to get you to do the equation part of it. The setup was good. Yeah. Be lightning fast. Okay, if you haven't gotten it done yet, you got to bring it up. I'm sure you will be getting lots of partial credit because I'm sure you did a setup and a table and everything else that we talked about. Looks good, Franklin. Nice setup on that. Nice sweatshirt. Very stylish. Okay, has anybody not brought their paper up yet? I need them. Okay, these are all the papers in, you guys? All right, so now let's talk about today's lesson. A little bit, we're not going to go over the do it because we just did the whole double thing with the quiz. Let's get to this. All right, so we are starting chapter 3. This is huge. What is this? Huge, super huge. Remember how I said that equations were like one of the most important skills that you could possibly get down pat for 8th grade math? Okay. Same side, opposite side, distribute, etc. Super important skills. This is, for those who take the state test, this topic is all over the state test. It is like white on rice, okay? So you had better be ready for this kind of stuff. The cool thing is, if you struggle with equations, this has nothing to do with equations. If there's things about the course that have given you a hard time so far, in some ways this is like a fresh start. Now we're not going to leave equations alone. They're going to be on every homework. We're going to continue to learn how to do them. And if you are someone who has struggled with equations, here is this relearn packet. It's chock full of examples that will get you better at your equations, and you will then be 100% prepared for everything going forward. But this is like a fresh start. So, if you said, man, some of the stuff that we've been doing so far has been driving me nuts, I feel lost, this is definitely a brand new beginning. So let me go through this here. Mr. Clark, you paying attention? Yes, sir. That was a fib, but from this point forward, let's pay attention. Now, okay, what's different about these lines? Yeah. Yeah, they're in different directions. I mean, first off, I like to read lines like I read a book. How do you read a book? Left to right. Left to right, top to bottom, okay? So we're going to go left to right here. Now, this one seems to be going up. This one seems to be going up. This is going up, but not as much, right? And this one's going what? Down. Now, this thing about a line, if you will, we could call this whether they're going up, whether they're going down, how much they're going up, we could call this steepness. How steep a line is or Steepness would be like, if you went upstairs that go like this, that's not very steep. Those are easy to walk up. But there are some staircases on the North Shore that I walk up, go like this. Yeah, and it's like, you're almost walking straight up and down. That's a really steep staircase. So we're gonna call this angle of the line, if you will, steepness for the next couple of days. And eventually that's gonna rotate into being interchangeable with the word slope, okay? So what if we take these exact same graphs, or lines, I'm sorry, and we put them on graphs? Now the advantage to putting these lines on graphs is that in putting it on a graph, I can actually measure it. All right? I measure it by having all of these little things here. There's, anybody here ever hear of a thing called hip dysplasia with a dog?
Yeah.
All right, it tends to happen with bigger dogs. And there's two ways that they measure hip dysplasia, and not even measure, but they kind of certify about it. One is a test called an OFA, where they take an x-ray of the dog's hips, and then once they take the x-ray of the dog's hips, they certify it as either bad or poor, fair, good, very good, excellent. But the problem with that is they give it to a bunch of x-ray guys who sit around, veterinarians, and they look at the pictures and they give their opinion on it. And that's nice, but different people might have different opinions. So sometimes some of the people look at the graphs and they say, or the x-rays, and they go, oh, that's good. Another one might go, I don't think that's very good. That's fair. Another one might say, nah, that's really good. But it's all opinion. Now they have a second type of test called a pen-hip test. With a pen-hip test, first off, they automatically pull the leg as far out as they can. Nothing to hurt the dog, but like if this is your arm hanging loose, they just pull a little bit, just a little bit. And when they pull it, they then have next to it all of these markings. And the markings tell you exactly how far each leg went out, so they can measure the amount of looseness in the hip. And that's what hip dysplasia is, it's the looseness in the hip. But they can actually count, like 1, 2, 3, 1, 2, and figure out the amount of looseness in it. So when we use and put these lines on a graph, we can count that steepness. We can figure out what that steepness is. So here's how I do it. It's really, really, really easy, okay? All I do is I take a point, and I always want to find a point that works perfectly like this one. It's right on where they meet. And I'm just going to count until I find another point that's perfectly on. Here it is right here. Now, how far do I have to go up and over to get to that point? Up how many? 2. And over how many? 1. So this thing that we want to call the steepness, or whatever we want to call it, eventually we're going to call it slope, it's the same thing, is going to be always a fraction. And the fraction will be on the top how much I go up and over, how much I go up, and on the bottom will be how much I go over. So we said that we went up 1, 2. And we went over how many? 1. So I would say for this line that the steepness is 2 over 1. Does that make sense? And can you see how this has nothing to do with equations?
Yeah.
Right? So it's like a brand new start for you guys who have been struggling a little bit. Let's try this second line over here on the right. Okay, so I have my first point here, and then I have another one that's perfect right here. How many did I go up and how many did I go over? Up how many? 1, and over how many? 3. So we would say that that steepness is 1/3. Okay? Try the next one. Yeah, that's fine. And that, you know what, that's a great point. Because as long as it's a straight line, no matter where you start and where you begin, it's always going to be up 1/3. That's how you kind of define the line. Okay, try that next and the last line. Now, as we read left to right with the line, what do you notice right away about this line compared to the other two? It's going down. Now, when lines are going up, it's positive. When they're going down, it's negative. So the first thing I want to be part of this answer is that it's going to be negative. Okay? Yep.
Negative 1/1.
That's right, it is negative 1/1. Because I'm gonna start here, I'm gonna go down 1/1, down 1/1, and as soon as it's down, what is it always gonna be? Negative, okay? So, and so basically with a graph, if it goes up, it's positive, if it goes down, it's
Negative.
negative. Hey, what do you think if it's perfectly horizontal? What do you think the steepness would be then? What number's right between positives and negatives?
0.
0, so that steepness would be 0. Yes?
Wait, can't, wasn't that like going up, like you counted the other way?
That's why I said we always go left to right. Okay, if you allow to go right to left, then it gets confusing. So we're just gonna go left to right, and if it goes up, it's positive, if it goes down, it's negative. All right, so let's go to the next series of pictures that we have. Now, this idea of steepness we also call slope. And I wanna emphasize that slope is a measure. That second type of working with the dog's hips, that's called a Penn hip test. And what's so good about a Penn hip test is it gives you a number attached to the hip. So they can't say, oh, these guys think it's good, these guys think it's bad, these guys think it's really good. Or you can't turn around and say, oh, I know the dog owner, I'm just gonna say it's good so that the dog owner can go breed the dog. It's not like that. Now you get an exact number, and when your dog gets its hips done, they actually compare it to all of the others in the breed. And it says, oh, this one's at the 50% mark, that means it's right in the middle. This one's at the 90% mark, that means it's better than almost everybody. Or this one's at the 80% mark. If you wanna breed your dog and you find out that the hips are at the 90% mark, you're like, yeah, this is a really good dog to breed. But then, if you find out that your dog is at the 10% mark, would you breed your dog? No, because your dog has major hip problems. And it's not anyone's opinion, it's measured. So we want to measure. Measure increases accuracy, and that's what slope does. Now, there are three kind of formulas for slope. One is called rise over run. The other is called change in y over change in x. The little triangle symbol means change in. What does the triangle symbol mean? Change in. Okay, so it's the change in the y, that's the vertical, over the change in the x, which is the horizontal. And the last is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll get into this one later. It looks a little confusing, it's really not. But for now, I want to focus on the middle one. That the slope is the change in y over the change in x. They're all saying the same exact thing. All those formulas are the same. It's like saying, hi, hello, aloha, hola, shalom. What's another way to say hello? Bonjour. Howdy, partner. All of those. It's all the same exact thing. It's just different ways of looking at it, but it is the same exact thing. Okay. For today's purposes, again, we're going to save this last one for later. I like to go with the middle one. Okay. What I would like you guys to do is find the slope of this guy right here. This first line in the upper left. Find the slope of that line, and then just write the slope right on the line. Okay, so if I find the slope, I start with one point that's on the line here. I want to get to another point. How did I have to move? Up 2 over 1, right? So there's my slope. By the way, did you notice that the symbol for slope is the letter M? For years I struggled with that. Why use an M? Don't you think you'd use an S? Right, slope? But we use an M because it's how you move. All right, so M actually works for this. All right, let's do this line right here. What's the slope of that line? Got to notice it goes down right away. So when you notice it goes down, that automatically affects your answer before you even figure out how much. Okay, so I'm going to pick 2 points here and here. All right, now, because it goes down, what is it automatically going to be? Negative, good. Here's my fraction. How much am I going down and how much am I going over? What is it? 1 over 2, good. So my slope is negative 1/2. Okay, now let's do this one over here. What do we get for the slope of that guy? up or down right away, that tells you positive or negative. And then you just gotta figure out how do you move from point to point to point. Okay, what do we got for our slope of this one? What is it? 1 over 1, good. Because I'm gonna go up 1 over 1, up 1 over 1, up 1 over 1, and there's my slope. Okay, let's try the next 2 on the graph. I gotta scroll up a little bit to get this on here. Yes, Elizabeth?
I know which one goes on top and which one goes on bottom.
Oh, the up and down goes on top. The change in y, this is the y-axis up here. So the y is gonna go up and down. By the way, I should mention one other thing here. This is important. See, the up goes in the top. It's change in y over change in x. So I go up, that goes in top, that's 1, and I go over, which is 1. But,
How do you get the fraction, like the one's on top, that's.
because it's the y, you change in the y. So that means you count up and down, that goes in the top, and then you go left and right, and that goes in the bottom. Now, I want to show you something else that's really cool, and one of the things I love about mathematics is how it all ties in together, and it makes a whole lot of sense. Not only could I look at this as up 1 over 1, up 1 over 1, but couldn't I look at it as up 3 over 3? But if I did 3 over 3, what would that reduce to? 1 over 1. So these two slopes are the same thing. And just like fractions reduce, so too do slopes reduce. And I find, I happen to love that about math. You know, I don't like getting in these arguments like in politics, you'll get people who argue and say, you know, this, that, or the other thing. They'll look at the same information and draw different conclusions. I don't like that. Okay, so let's go to this line right here, okay? Find the slope of that line. Should be able to tell right away if it's positive or negative. Okay, is this a positive or a negative? Everybody? Negative. Negative. And now, oh, it shouldn't be -1, it's just negative. Why am I writing -1? Negative and then line. Okay, if I go from here to here, what did I go down? 2 over 1. Good. All right, let's do this guy over here, the last one. What's the slope of that line? The steepness, if you will, of that line. Is this positive or negative, guys? Positive. Who said negative? Positive. Come on, head in the game.
I see something else.
Here's my fraction. We always love to write slopes as fractions because it tells us how much up, how much over. All right, let's see. I'm going to go from, oh yeah, these points are ugly. All right, well, let's see if I keep extending. All right, this one's going to be tough. Let's make a point here and a point here. Let's just make those 2 points. You everybody see them? Put this one down on the line right here and put this one down on the line right here. Now count it. Okay, so what am I going to do? I'm going to go up how many? 2 over how many? 4, and that could reduce to what? 1/2. They're both right. You don't get the answer wrong if you write 2/4. Okay, let's be clear about that. All right, let's keep going forward just a little bit more. In the space above, draw a line whose slope is 2, 3, passing through the point 1, 2/3. All right, we'll do a little bit more with this on Monday. You can finish the rest of the homework. Hey, hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot, ciao, arrivederci, adios amigos y amigas. Cheerio, you all right?
Yeah.
All right, you're smiling now, you haven't smiled all period. Flip-flop still, huh?
I'm not stopping wearing them to around maybe New Year's.
Well, you gotta watch the temperature. If it's a warm year, that's not a problem. If it starts getting into the 30s,
Yeah, that I don't.
you're being stubborn for,
Kamito, please come to the main office,
What's that?
please.
How do you make it?
no, everything goes left to right. So if I read it left to right, is it going up or down? Like if you read this, you go this way, right? S-L-O-P-E. So now I'm gonna read it this way. If I read it this way, am I going up with the line or am I going down with the line?
I don't get it though. I don't get what you mean. Go off.
Okay, you know left from right, right?
Yeah.
Okay, so now, This is the left side of the page, this is the right side of the page. So let your eyes just go this way. So let's take a look at this line up here. As my eyes go from this way to this way, is this line going up or is it going down? Down, right? Like if you're walking downhill, since it's going down, that one's a negative. Now let's have our eyes just look at this line here. As you go from left to right, is this line going up? So that's positive. Take a look at this one. As I go from left to right, am I going up? Or am I walking up a staircase or down a staircase? So that would be negative. If this was the staircase, would I be walking up or down? So that's positive. This one? Am I going up? Yes, I am. So that's positive. So anytime it's like you're going up the staircase, walking left to right, it's positive, and if you're going down the staircase, negative.
Okay.
All right?
That makes more sense.
There you go. All right, see you later, Uni.
Okay, thank you.
You're welcome.
I forgot my book.